Let's discuss how to handle math problems on the real estate exam. A nice formula to use that will work on most of our math problems is called the power principle. We call this the power principle because it centers on the letters P, W, and R in the word power. The first thing we do is we draw a T. A lot of folks will refer to this as a T formula. In the T formula, the P stands for the word part, which is always the smaller number in the equation or problem. The part always goes on the top. The W stands for the word whole, which goes in the bottom left in our T. That is always the largest number you'll have in the problem. The R in the word power stands for the word rate, which always will be in the bottom right of our T, and that is always a percentage. What we'll be able to do on most math problems is put in two of the three variables every single time, and then by either dividing or multiplying, we can solve for the third. The key is, when do you divide and when do you multiply? With the power principle or the T formula, we always work top to bottom and left to right. When we go top to bottom, we always divide. Think of that horizontal line as a great big divided by sign. So it is always the top number divided by one of the bottom two numbers. Likewise, when we go left to right, we multiply straight across. Notice our vertical line has a multiplication sign. Let's put this into practice. Let's say in a math problem, they give us the part and the whole and ask us for the rate. In this case, our two known variables are separated by our horizontal line, which tells us to divide. So we would take the part and divide by the whole to arrive at the rate. Let's put some numbers in to illustrate. Let's say a question says 8 is what percent of 50? In this case, 8 is a smaller number, so it goes up on top for the part. 50 is our larger number. It goes in the bottom left for the whole amount. So our formula says to take the top and divide by the bottom. So if we take 8 and then enter divided by 50, your calculator probably shows an answer of 0.16 for the rate, which is 16%. Most calculators have a percent key on them. An easy way to use the calculator is to utilize that percent key. So let's try this. Take the number 8, then hit divided by, and then hit the number 50. Rather than hitting your equals button, I want you to find the percent key and hit the percent key. If you do that, the number should flash up on your screen that says 16 for our answer of 16%. Some calculators you have to hit percent and then equals first. So the key is, if you want your answer on a percentage basis, just hit that percent key. So 8 divided by 50, hit percent, boom, there's our answer, 16%. On a different math problem, they might give us the whole and the rate and then ask for the part. So in this case, our two known variables are separated by the vertical line, which tells us to multiply straight across. So a question might say, what is 30% of 600? In this case, 600 is the larger number. It goes in the bottom left for the whole amount. Our rate is 30%, which goes in the bottom right for the rate. Our formula tells us to multiply straight across. So we would take 600 times 30%, and that would give us the part, or our answer, of 180. Our answer would be 180. Again, use your percent key. If you take 600, then hit times, then hit the number 30, then hit your percent key, most calculators will flash up a number that says 180. Our last illustration is where in a math problem they might give you the part and the rate and ask for the whole. In this case, our two known variables are separated by our horizontal line, which tells us to divide. So we'll take the top and divide by the bottom, part divided by rate. The question might be, 80 is 40% of what number? In this case, 80 is a smaller part of a larger number. What is that larger number? So 80 would be the part and goes up on top. Our rate is 40%, which goes in the bottom right. And our formula says to take the top number and divide by the bottom number. So we would take 80, then hit divided by, then hit the number 40, then hit your percent key, and then equals if necessary, and the whole amount will be 200. Our answer would be 200. Keep in mind that generally speaking on math problems, every percentage they give you in the math problem will be a separate t. So in a math problem, if they give you 1 percentage, that's typically going to be 1 t. If they give you 2 percentages, then we'll have 2 t's. 3 percentages, 3 t's. That's not 100% of the time, but that's something you can generally use as you work these problems. The percentages typically equate to a separate t calculation each time. Let's tackle some problems involving real estate taxes. Let's say a problem says, a property with a market value of $240,000 had a tax assessment rate of 25%. What would be the assessed value? In this case, the math problem gives us 1 percentage, so that tells me I will need to draw 1 t. I always like to put the percentage in first if possible because the percentage always goes in the bottom right in our t. So I'll put 25% in the bottom right. The total market value is $240,000. That would be the whole amount and go in the bottom left. So our formula tells us to multiply straight across. So we would take $240,000 times 25% to give us an assessed value of $60,000. That will be our part, and that will be our answer, $60,000. Let's say a problem begins with something like this. A property with a market value of $80,000 was assessed for tax purposes at 30%. The mill rate for the taxes was $55,000. What would be the amount for the real estate taxes? To begin with, let's discuss a mill rate. A mill rate is a per thousand rate, which is where the taxes are based on a per thousand of value. We will convert that to a percent rate, which will tie into our T formula. So we will have a tax rate here, a mill rate for the taxes, and we'll also have the assessed value of 30%. So we will have 2 percentages, which means we draw 2 t's. Let's begin with the assessed value. 30% in our first t goes in the bottom right. The total value is $80,000, so our formula tells us to multiply straight across. So we would take $80,000 times 30% to give us our part or assessed value of $24,000. We pay taxes based on the assessed value. We take the assessed value times the tax rate. Here, the tax rate given is in mills, which is 55. That would be 55.00. The easiest way to convert a mill rate to a percentage is to simply take your decimal place and move it 1 place to the left. So if we move that decimal 1 place to the left, that will give us a 5.5% tax rate. We can then put this into our second t. 5.5% will go on the bottom right. The assessed value of $24,000 will be the larger number that goes in the bottom left. So our formula says to multiply straight across. So we will take $24,000 times 5.5%, and that would give us our part, or the taxes on this property, of $1,320, and that would be our answer. A problem might say that a property with a market value of $150,000 had a tax assessment rate of 20%. The tax rate was $3 per hundred of assessed value. Per hundred means percent, so that's the same thing as 3%. The amount of real estate taxes would be, once again, they give us 2 percentages, which means I draw 2 t's. Let's begin with the first t and figure out the assessed value. The tax assessment rate is 20%, which goes in the bottom right. The total market value is $150,000, which will be the whole amount, the larger number, that goes in the bottom left. Our formula says to multiply straight across. So we would take $150,000 times 20%, and that will give us our part, or our assessed value, of $30,000. The assessed value is what we pay the taxes on. So in our second T, we know that the tax percentage is 3%. That goes in the bottom right. The assessed value will be the larger number, 30,000. That's our whole amount. That goes in the bottom left. Once again, our formula says to multiply straight across. So we will take 30,000 times 3%, and that will give us our part, or the actual amount of taxes, of $900 on this property. $900 would be our answer. A problem might say that a property had a tax assessment rate of 25%. The actual taxes paid for the year were $1,500. If the tax rate was $6 per thousand, remember per thousand is a mill rate, the total value would be. Well, in this case, we will convert the mill rate to a percentage rate. So once again, in our math problem, we have two percentages, therefore we draw two T's. Let's begin with the actual taxes paid of $1,500, and let's look at that tax rate. $6 per thousand, that would be 6.00 for our mill rate. To convert a mill rate to a percentage, we take our decimal place and move it one place to the left. So that will convert a 6.00 mill rate to a 0.6% tax rate on a percentage basis. So in our first T, 0.6% goes in the bottom right for the tax rate. Our taxes for the year are the part. They're a smaller number compared to the value, so that goes up on top for the part. So our T formula tells us to take the top number and divide by the bottom number. So if we take $1,500 and divide by 0.6%, that gives us an assessed value of $250,000 for the whole amount. Let's next go to our second T formula here to figure out the total value. All we have so far is the assessed value. The assessed value represents 25% of the total value. So in our second T, 25% goes in the bottom right. The assessed value of $250,000 would be the smaller number. It goes up on top for the part, which now we know to divide the top number divided by the bottom number. So we would take $250,000 and divide by 25%. That gives us the total market value of $1 million. $1 million would be our answer. Let's discuss some math problems that might involve interest calculations. Let's say a problem says that a buyer purchased a property obtaining an 80% loan. The monthly interest paid in the first month was $800. The interest rate on the loan was 5%. Interest rates are always quoted on an annual basis. What would be the total sale price on this property? To begin with, we have two percentages in our math problem, which tells us to draw two T's. Let's begin with the monthly interest of $800. Since the annual interest rate is 5%, we need to equate that with the annual interest paid. So we will take the $800 times 12 months to arrive at $9,600 total interest for the first year. We then go to our T formula. The interest rate on the loan was 5%, and the percentage always goes in the bottom right. So 5% goes in the bottom right of our first T. The $9,600 in annual interest paid will be a smaller number in relationship to the loan amount. So the $9,600 goes up on top. We therefore take the top number and divide by the bottom number. So we will take $9,600 and divide by 5% to give us our whole amount, or loan amount, of $192,000. Once we have this number, we know that the loan represents 80% of the total value. So to get the total value, we'll go to our second T. Our percentage is 80%, which goes in the bottom right. The loan amount will be a smaller number in relationship to the value, so the $192,000 is the part. So we then take $192,000 and divide by 80% to come up with a total value of $240,000. That would be the whole amount, or our answer, $240,000. Let's say a problem says that a property was purchased with the buyer obtaining a $180,000 loan. The interest rate on the loan was 4% with a 30-year term. Monthly principal and interest payments were $1,079.20. What was the total amount of interest paid on this loan over the 30-year term? This is the one time we do not have to use a T. Let's look at the monthly payment of $1,079.20, which represents the principal and interest payments. Let's take the $1,079.20 times 12 months to find out how much we pay each year in principal and interest, and that will give us $12,950.40. Since this is a 30-year term, the borrower will pay that annual amount over 30 years. So if we take $12,950.40 times 30 years, that gives us a total payback of principal and interest over the entire loan of $388,512. That represents P&I, or principal and interest. Let's then subtract out the loan amount of $180,000, which is the principal. The principal is your loan amount, and the balance will be how much had to be applied to interest. So if we take $388,512 minus $180,000, that means the amount going toward interest over the entire 30 years was $208,512. Our answer again would be $208,512. Let's say a problem says that a buyer purchased a property obtaining an 80% loan on a 10-year straight note. A straight note is also called a term loan, which means we have equal amounts of interest each month. The interest paid over the first 3 years was $18,000 with an interest rate of 6%. Remember, interest rates are always quoted on an annual basis. What was the purchase price of the property? In this case, I once again have two percentages in the math problem, so we will draw two T's. Let's first off look at that 6% annual interest rate. That has to equate to annual interest paid. We have $18,000 of interest paid over 3 years. And since a straight note is equal amounts of interest each month, we can simply take the $18,000 and divide by 3 years, which means that we paid $6,000 in interest per year. Let's then go to our T formula. The 6% interest rate will go on the bottom right for the percentage. The $6,000 in interest will be the part, that's a smaller number in relationship to the loan amount. So our formula tells us to take the top number and divide by the bottom number once again. So we will take $6,000 and divide by 6%. That gives us our whole amount, or our loan amount, of $100,000. That will be on the bottom left, $100,000. Notice that the loan represents 80% of our total value. So now we go to our second T. We know where 80% goes, bottom right for your percentage. The $100,000 loan will go up on top for the part, because the loan amount represents part of the total value. So we take $100,000 and divide by 80%, and that gives us our whole amount for the total value of $125,000, and that would be our answer. Let's tackle some math problems involving discount points. A problem might say that a buyer purchased a property for $150,000, obtaining a 90% loan. The lender charged 2 discount points. Please remember that a discount point equals a percentage. So if a lender charges 1 discount point, or 1 point, that would equate to 1%. If a lender charges 2 points, that would be 2%. And also remember that discount points are always based on the loan amount, never the sale price, always based on the loan. The question would then say, how much in dollars were the points? In this math problem, we have 2 percentages, so we would draw 2 T's. Let's first off figure out the loan amount. I have a 90% loan, so in the first T, 90% goes in the bottom right for the percentage. The $150,000 purchase price is the whole amount, or largest number I have, which goes in the bottom left. So our formula tells us to multiply straight across. So we will take $150,000 times 90%, and that will give us our part or our loan amount of $135,000. Let's now go to our second T. We have two discount points, which is 2%, and that's based upon the loan amount. So 2% goes in the bottom right. The loan amount this time will be our whole amount on the bottom left, $135,000, because the loan amount number will be larger than the amount of discount points. Hence, it is the whole here. So our formula tells us to multiply straight across. So we would take $135,000 times 2%, and that will give us our part, or the amount of discount points in dollars, of $2,700. So our answer is $2,700. A problem might say that a buyer paid $3,000 in discount points as the lender charged 2 points, which once again is 2%. The loan-to-value ratio was 75%. What was the purchase price of the property? In this problem, I have two percentages, so we draw two T's. In the first T, let's look at the actual discount points of $3,000. The $3,000 in discount points were based on 2 points that the lender charged. So in our first T, 2% goes in the bottom right for the percentage. The amount of discount points, 3,000, will be the smaller number, goes up on top for the part, so I take the top and divide by the bottom. $3,000 divided by 2% will give us our whole amount, or the actual amount of the loan, of $150,000. The loan amount then represents 75% of the total value. That's what a loan-to-value ratio means. What percent is the loan to the total value? So in our second T, 75% goes on the bottom right. Our loan amount will be the part, because it's a smaller number in relationship to the total value. So we take the top and divide by the bottom. We will take $150,000 and divide by 75%. That gives us a total purchase price of $200,000. So $200,000 would be our answer. That is the whole amount here. A problem might say that a buyer purchased a property for $100,000, obtaining an 80% loan. The lender charged 0.5% for the PMI insurance, which is insurance in case the borrower defaults. What would be the monthly amount now? Monthly amount for the PMI, or private mortgage insurance. In this case, the math problem gives us two percentages, so we draw two T's. Let's begin and figure out what the loan amount is. Notice that the loan is 80% of the total value. So in our first T, 80% goes in the bottom right. On the bottom left for the whole amount, that will be the $100,000 purchase price. So our formula tells us to multiply straight across. So we would take $100,000 times 80%, and that would give us $80,000 for our part, or for our loan amount. In the second T, we can now base the private mortgage insurance, or PMI insurance, on that loan amount, and it is 0.5%. So in our second T, the 0.5% goes in the bottom right. The $80,000 loan will be the whole amount, the larger number, goes in the bottom left. So our formula tells us to multiply straight across. So we will take $80,000 times 0.5%, and that will give us the annual PMI insurance of $400. That will be the part. But notice the question asks for the monthly amount for the PMI. The PMI is equal each month. So we simply take the $400 and divide by 12 months. That will give us the monthly amount for the PMI of $33.33. That would be our answer. A problem might say that a buyer purchased a property for $200,000, obtaining a 90% loan. The lender charged 2 discount points, once again that's 2%, and $3,000 in closing cost. What is the total amount due at closing from the buyer? Notice the key words, the total amount due. This problem has 2 percentages, so once again we draw 2 T's. Let's begin with the 90% loan. The 90% goes in the bottom right. The entire purchase price will be the largest number, which is $200,000, which goes in the bottom left. So our formula tells us to multiply straight across. We will take $200,000 times 90%, and that will give us the part, or our loan amount, of $180,000. Discount points are always based upon the loan amount, so we can now go to our second T. 2 discount points is 2%, so 2% goes in the bottom right. The loan amount of $180,000 will be the whole amount on the bottom left. So our T formula tells us to multiply straight across. We will take $180,000 times 2%, and that would give us the amount of discount points of $3,600. That would be the part, or the dollar amount, for the discount points. So to finish out, let's look at the total amount due at closing from the buyer. We know that the buyer will owe the $3,600 of discount points. We know that the buyer will also owe $3,000 in closing cost. But be careful, the buyer also owes at closing the down payment money. The down payment would be the $200,000 price minus the $180,000 loan. That result would give us $20,000 for the down payment, and that is also due at closing from the buyer. So we have to add all three numbers together, the $20,000 down payment, plus the $3,600 in discount points, plus the $3,000 in closing cost, to come up with the total closing cost due from the buyer at closing to be $26,600. And that's our answer. Let's look at some math problems involving commissions. A math problem might say that a property sold for $120,000 with the listing brokerage company charging a 5% commission. What would be the total commission owed by the seller? In this case, I simply have one percentage in the problem, so I draw 1T. The 5% always goes in the bottom right for the rate, so that's where I put my 5%. The $120,000 sale price is the largest number. That will go in the bottom left for the whole amount. Our T formula tells us to multiply straight across. So we will take $120,000 times 5%, and that will give us the part, or the amount of the commission, of $6,000, and that would be our answer. Let's say that a problem says that a licensee listed a property for sale for $190,000 with the listing brokerage company charging a 6% commission. The listing brokerage agreed to cooperate with other brokerage companies offering a 50% commission split. A licensee of a cooperating brokerage did produce a buyer who offered $180,000, which the seller accepted. If the cooperating selling broker, the selling broker is the name given to the cooperating company, agreed to share 40% of the commission with the licensee, how much would the selling broker's licensee receive? In this case, they give us 3 percentages in our problem, which tells us we will draw 3 T's. Let's begin with the total commission. The sale price was actually $180,000, so that will go in the bottom left in our first T for the whole amount. My commission rate is 6%. Your percentage always goes in the bottom right. So our formula tells us to multiply straight across. So we will take $180,000 times 6% to get the part, or the total commission, of $10,800. Let's now go to our second T. Since the commission will be split 50% for the listing company and the selling company, we will use 50% in the bottom right-hand portion for our split. The total commission of $10,800 will be the whole amount, which goes in the bottom left. So we multiply straight across. We will take $10,800 times 50%, which gives us the part, or $5,400, is the amount going to each brokerage company. $5,400 to the listing brokerage company and $5,400 to the selling brokerage company. Then the selling broker agreed to share 40% of the commission with their licensee. So how much will the licensee receive? So in the third T, our percentage will be 40%, which goes in the bottom right. The selling brokerage's total share was $5,400. That will be the whole amount on the bottom left. So we multiply straight across. We will take $5,400 times 40%, which will give us our part, or the amount for the licensee to receive, which will be $2,160. So $2,160 will be our answer. A problem might say that a property sold for $220,000, with the seller responsible for a 7% commission fee owed to the listing broker. The seller also had a first mortgage of $150,000 and agreed to pay closing costs of $2,500. What would the seller net out on this transaction? In this math problem, they only give us one percentage amount, which means we'll have one T. What we need to do is take the total price and subtract out all of the seller expenses to find out what the seller nets. Let's first off draw our T and figure out the commission. Our 7% commission goes on the bottom right. The $220,000 purchase price goes on the bottom left for the whole amount, so our formula tells us to multiply straight across. We will take $220,000 times 7%. That will give us a total commission of $15,400. That would be the part up on top. We can now solve the problem. We then take the $220,000 sale price minus the commission of $15,400 minus the first mortgage that the seller owes of $150,000 minus the $2,500 of closing costs that the seller is going to pay, which will give us a seller net of $52,100, and that would be our answer. A problem might say that a seller netted $149,000 on the sale of a property. If the seller paid closing costs of $3,000 and a 5% commission, what would be the sale price for this property? Anytime they give us a property where the seller nets out so much money and we have to figure out the total sale price of the property, here's the easiest way to do that in a straightforward manner. Let's start off with what the seller nets out and add in all of the costs that the seller is going to have to pay. So we will take the seller net of $149,000 and add the $3,000 of closing costs the seller will have to pay. That will give us a subtotal, if you will, of $152,000. However, the seller wants to make sure they receive $152,000, which will be enough to pay off the $3,000 in closing costs and net $149,000, but yet the seller says the commission has to be on top of that, so just add the commission on top. We cannot add the commission on top because the commission is given as a percentage, not an actual dollar amount. So in our T formula, let's draw ourselves one T. Here's what we would do. The total sale price, which is what we're looking for here, that's going to represent 100% of the total number. Of that 100% of the sale price, the seller has to give 5% of that back to the brokerage company, which then only leaves 95% remaining of the sale price for my seller to keep. And that 95% has to equate to $152,000 to make this work. So in our T, 95% goes on the bottom right. That's the percentage. The $152,000 is part of the total sale price. That goes up on top for the part. Our formula tells us to take the top number and divide by the bottom number. So if we take $152,000 and divide by 95%, that gives us our sale price of $160,000 for the whole amount, and that would be our answer. Many people make the mistake of wanting to take the $152,000 times a 5% commission added on top to come up with the sale price. That doesn't work because you're now basing a 5% commission on something other than the sale price, and that's why you cannot do that. If you come across a problem like this, you can always work it backwards. Let's see if we're correct. We believe that the answer for the sale price is $160,000. If I were to take $160,000 as a whole amount in a T here, just to check ourselves, and then put 5% commission on the bottom right and multiply across, we would have $160,000 times 5%, which means the commission would have been $8,000. That would have been the part. So to find out what a seller nets, we take the sale price and subtract out the seller expenses. So if we take a sale price of $160,000 minus the $8,000 of commission minus the $3,000 of closing cost, sure enough, the seller nets out $149,000, and that's exactly what our problem tells us, so we have this one for sure correct. You can always take all four possible answers on your exam if you have a problem like this, and take those four possible sale prices times the commission rate, subtract out all the numbers. One of them will have to subtract down to the $149,000. Whichever one it is will be our answer. Let's next talk about some math problems involving prorations and closing statements. A problem might say that a property is sold for $100,000 with the seller responsible for a 6% commission. The buyer who purchased the property obtained a 90% loan. If the seller agreed to pay 2 discount points and a 1% loan origination fee, what would be the seller's total closing cost for this transaction? In this math problem, we have 4 percentages given to us, which means we draw 4 T's. Let's begin and figure out first off the total commission that the seller has to pay, because we're looking for the seller's total closing cost. Commission is based upon the sale price, which is $100,000. So in our first T, the 6% commission goes in the bottom right. Our $100,000 sale price is the largest number we have. That will go on the bottom left for the whole amount. And then our formula tells us to multiply straight across. So we would take $100,000 times 6%. That would give us our part, or the amount of commission, of $6,000. The next two items, the discount points and loan origination fee, are based upon the loan amount, not the sale price. So in our second T, we need to figure out the loan amount, which is 90% of the total sale price. So 90% goes on the bottom right. On the bottom left is our whole amount, the $100,000 purchase price. So our formula tells us to multiply straight across. If we take $100,000 times 90%, that gives us our part, or our loan amount, of $90,000. Now that we have the loan, we can figure out the discount points and the origination fee. So in our third T, the discount points are 2 points, which equate to 2%. So 2% goes in the bottom right. The $90,000 loan amount will be the whole amount, the larger number, on the bottom left. Our formula says to multiply straight across. So we take $90,000 times 2%, and that will give us $1,800 as the part for the discount points. Our fourth T will be the 1% loan origination fee. So 1% goes in the bottom right. The $90,000 loan amount is the whole amount on the bottom left, and our formula says to multiply straight across. So we take $90,000 times 1%, and that would give us our part, or the loan origination fee, of $900. The last thing we need to do is simply add the 3 different closing cost amount together. So we will take the $6,000 in commission, plus the $1,800 in discount points, plus the $900 for the loan origination fee, and the sum of all 3 of those items added together is $8,700, and that would be our answer, $8,700. Let's say a problem said that a rental property sold with the closing date of October the 17th. The monthly rent was $1,200, which had been paid on October 1st. Rent is typically prepaid. Assuming the seller is credited with the day of closing, how much rent money would the seller owe the buyer at closing? On prorations on the examination, we will use a 360-day year or a 30-day month unless told otherwise. If they tell you in a problem to use a calendar year, then you would have to use the actual days in each month. But absent that, we will assume every month has 30 days. Let's draw a timeline. Timelines are very helpful with proration problems. We are dealing with the month of October. So on the far left, the beginning of our timeline, the date we will put will be October 0. We put 0 because that represents the first day of the month. So we have October/0, 10/0. On the far right end of our timeline, we have October 30th. So we will put 10/30 for October 30th. That's the end of the timeline, again assuming every month has 30 days. In the middle, we'll put 10/17 for October 17th. On prorations, the money has to be paid either at the beginning of the timeline or the end of the timeline. I always like to put a dollar sign where the money is paid. In this case, the money is paid on October 1st, so I will put my dollar sign right above October 0, or the 1st of October. Wherever you draw your dollar sign, you always prorate the opposite end, which means the time frame we're looking for is from October 17th through October 30th. Just as a quick aside, if money is paid at the end of the timeline, like typically with real estate taxes, you would put your dollar sign at the very end of the timeline, which tells us to prorate the opposite end, which will be the front part of the timeline. So on prorations, draw your timeline, put your dollar sign either at the very beginning or the end, depending on if it's prepaid or paid in arrears, which means at the end, and then you'll always prorate the opposite end. In this case, we need to know how many days we have between October 17th and October 30th. Let's draw two columns. The first column headed months, the second column will be headed days. We will subtract the earlier date from the later date. So we put right underneath our columns for months and days, we put the number 10 under months for October, and under the days we'll put 30 for October 30th. Then below that we will subtract October 17th. So under months we put 10, under days we put 17. Then we subtract. And we subtract the same way they taught us to back in grade school. We start at the far right, work our way back left. So 30 days minus 17 days is 13 days. 10 months minus 10 months is 0. So what this tells us is that we have 13 days here for the prorated rent. Basically, the buyer who closes on this rental property on October 17th deserves the rent money from October 17th to the 30th. Who already has that rent money is the seller of the rental house, who collected the entire rent money for the whole month, October 1st through October 30th, on the 1st of October. So the seller has to give 13 days of the rent money back to the purchaser of this rental property. Keep in mind the tenant has nothing to do with this proration. This is simply between the seller and the investor buyer. We then break down the total rent into days. $1,200 was the monthly rent. So we'll take $1,200 and divide by 30 days, because we're using 30 days in a month. That would give us $40 in rent per day. The seller owes 13 days to the buyer. So we would take $40 per day in rent times 13 days. That would give us an answer of $520. That is the amount that the seller owes the buyer. A problem might say that a property which had annual real estate taxes paid in arrears, which means at the end of $3,600, sold with the closing date of May 15th. Assuming a 360-day year, what would be the real estate tax proration for this transaction? First thing we do is draw a timeline. Our timeline starts on January 0, which is 1/0, in essence January 1st. The end will be December 30th. So at the end of the timeline, we put 12/30. Our closing date is May 15th, so in the middle, we put 5/15. In this case, the taxes are paid in arrears, which means at the end, so I put our dollar sign above December 30th, which tells us that we always prorate the opposite end, which means this proration will be from the 1st of January, January 0, through May 15th. Let's find out the time frame. We set up our columns for months and days, and we always subtract the earlier date from the later date. So the first line under our columns will have 5 that goes under the month and 15 that goes under the day column. Underneath that, we'll subtract under the month column 1 for January and 0 for the days. So we have May 15th minus January 0. So we subtract. On the days, 15 minus 0 is 15 days. On the months, 5 months minus 1 month is 4 months. So the amount that the seller will owe for their fair share of the taxes, because recall the taxes have not been paid yet, will be 4 months and 15 days. Let's convert that straight to days. We'll take 4 months times 30 days in a month to give us 120 days, plus 15 extra days in May to give us a total of 135 days. 120 plus 15 gives us 135 total days the seller owes for the taxes. We then have to figure the dollar amount for the taxes. The taxes are $3,600 for the year. So if we take $3,600 and divide by 360, that is going to be our 360-day year or 30-day months. But if we divide by 360, that gives me $10 per day for the taxes. Again, $3,600 divided by 360 for the year is $10 a day for the taxes. We then take 135 days times the $10 per day for the taxes to get $1,350 for the taxes owed by the seller. Our answer again is $1,350. Let's discuss a few more math problems on prorations and closings. Let's say a problem says that a buyer purchased a property for $160,000, obtaining a 90% loan. The loan was obtained with a 5% interest rate, with closing to take place on July the 20th. Assuming a 360-day year, and the buyer's lender wants interest for the day of closing, which is typical, how much would the prepaid interest be for this transaction? Prepaid interest is what the buyer will pay basically from the closing date till the end of that current month. Let's draw ourselves a timeline as we begin. We are in the month of July, so the very beginning of our timeline will be 7/0 for the 1st of July. The end of the timeline will be 7/30 for July 30th, again using a 30-day month. The closing is on July 20th, so in the middle we'll have 7/20. The buyer will owe interest from the closing date of July 20th to the end of the current month, which will be July 30th. So let's set up our columns for months and days. We always subtract the earlier date from the later date. So the first entry under the months will be 7 for July, and then 30 under the day column for July 30th. Below that, we'll subtract from that July, the number 7, and the days will be the number 20 for July 20th. So we have July 30th minus July 20th. On the day column, 30 days minus 20 days is 10 days. The months cancel. 7 minus 7 is 0, so we have 10 days. There's one catch. By going through this subtraction process, we automatically give the seller responsibility or credit for the day of closing. Prepaid interest is the one item where the buyer's lender wants interest for the day of closing, so the buyer will be responsible this time for the day of closing, which means the buyer is responsible for 1 extra day. So we have to take our 10 days plus 1 extra day to come up with 11 days of prepaid interest. The 11 days will be inclusive of the beginning and ending dates of July 20th and July 30th. Worst comes to worst, use your fingers and toes and count them up. If we count them up with ones here on our screen, and we say July 20th, 21st, 22nd, 23rd, 24th, 25th, 26th, 27th, 28th, 29th, 30th, sure enough, we add all those tallies up, that is 11 total days of prepaid interest. Let's next draw ourselves 2 T's, because the math problem gives us 2 percentages. Let's first off figure out the amount of the loan. We have a 90% loan, so in the first T, 90% goes on the bottom right. The sale price is $160,000, which goes in the bottom left for the whole amount. Our formula tells us to multiply straight across. So we will take $160,000 times 90%. That will give us the part or the loan amount of $144,000. Let's go to our second T. The interest rate of 5% is based upon that loan of $144,000. So in the second T, 5% goes in the bottom right for the rate. Our loan amount is the larger number or the whole amount. That goes in the bottom left, $144,000. Our formula tells us to multiply straight across. So we will take $144,000 times 5%, and that will give us our part, or $7,200, for the amount of annual interest. That's interest for the year. We then break down the annual interest to daily interest. And to do that, we take $7,200 and divide by 360, that's our days per year, and that gives us $20 per day for the interest on the loan. Our buyer owes 11 days of prepaid interest. So we will take $20 per day of interest times 11 days. That gives us a total of $220 of prepaid interest, which would be our answer. Let's say a problem says that a seller sold a property for $130,000 with a closing date of August the 10th. The seller's loan balance at closing was $86,400 with a 5% interest rate. How much would the accrued interest be on this transaction? Accrued interest is what the seller owes on the seller's loan. Keep in mind that mortgage payments are paid in arrears, which means at the end. So at the end of the month, or the first of the next month basically, we pay our mortgage payment, which pays off the previous month's interest. Normally, the month of August, the interest on the loan would be paid with a September 1st mortgage payment. However, we never get to September 1st because the seller sold the property on August the 10th. So we need to figure out how many days of accrued interest the seller owes on this loan. Let's draw our timeline. We're in the month of August, so the very beginning of our timeline will be 8/0 for the 1st of August. The end of the timeline will be 8/30 for August 30th. And in the middle, we'll have 8/10 for August 10th, our closing date. In this case, the seller will owe interest from the 1st of August through August the 10th. Because again, that was never paid because it accrues and it's always paid in arrears. So let's set up our columns for months and days again. We always subtract the earlier date from the later date. So the first entry under the columns of months and days, under the months column, we'll have 8 for August. Under the days, we'll have 10 for August 10th. We'll subtract from that, under the months, 8 for August, and 0 for the days, which is the 1st of August. So we have August 10th minus August 0 in essence. So under the days, 10 minus 0 is 10 days. 8 months minus 8 months is 0, so that cancels. So we have 10 days of accrued interest. Let's next draw a T and figure out the amount of interest. Our interest rate is 5%, which goes on the bottom right. Our loan amount is going to be $86,400. That was the loan balance at closing, $86,400. So our formula tells us to multiply straight across. We take $86,400 times a 5% interest rate. That gives us the part, or the interest paid on a yearly basis, of $4,320. Recall, interest rates are always on an annual basis. We need to figure out the amount of monthly interest. So we would take the $4,320 of annual interest and divide by 360, and that would give us $12 per day of interest on the seller's loan. The seller owes 10 days of accrued interest. So we would take the $12 in interest per day times the 10 days, which would give us $120 for the total amount of accrued interest on the seller's loan. A problem might say that a commercial property required a tenant to pay a base rent of $3,000 per month, plus 5% rent on annual sales that exceeded $90,000. If the annual sales were $120,000, what would be the total annual rent paid by the tenant? Let's first off take a look at the base rent. The tenant pays $3,000 per month no matter what. So we would take $3,000 times 12 for 12 months. That would give us $36,000 in annual base rent for the tenant. This tenant is also paying rent on a percentage basis, but it's only on sales exceeding $90,000 for the year. So if we take $120,000 total annual sales minus the $90,000 base, if you will, that gives us excess sales of $30,000 on which to compute percentage rent. Let's next draw a T. The percentage rent is 5%, which goes on the bottom right for the rate. The $30,000 of excess sales will be the whole amount, the larger number, which goes on the bottom left. Our formula says to multiply straight across. So if we take $30,000 times 5%, that will give us our part, or $1,500, for the percentage rent. So to finish the problem, for the total rent paid by the tenant, we will take the base rent annually of $36,000 plus the $1,500 extra on their percentage rent to get a total rent amount of $37,500, and that would be our answer. Let's tackle some math problems involving measurements. A problem might say how many 100 by 200 foot lots could be made in a piece of ground that contain 1 acre with 3,560 square feet taken out for streets. Let's first off figure out the total square footage of our lots. To find the area or the square footage of something, we take the length times the width. So we would take 100 feet times 200 feet. That would give us 20,000 square feet for our lots. A square with a slash through it is our abbreviation for square feet. Next, we need to find out how many total square feet we have in our 1 acre of land. Here's where you have to memorize that every acre contains 43,560 square feet. So we will take 43,560 total square feet and first subtract out the amount taken out for the streets, the 3,560 square feet. So if we take 43,560 minus 3,560, that leaves us 40,000 square feet left over for our development. Each of the lots will contain 20,000 square feet. So if I take 40,000 square feet total left over and divide by 20,000 square feet, that means that we can put 2 lots into this development. Our answer would be 2. Let's say a problem says that 2 rooms in a house needed to be recarpeted. One of the rooms measured 10 feet by 12 feet, and the other room measures 15 feet by 19 feet. How many square yards of carpet will be needed to carpet both rooms? Let's first off determine the square footage of each room by taking the length times the width. So for the first room, if we take 10 feet times 12 feet, that will give us a total of 120 square feet. For the second room, if we take 15 feet times 19 feet, that will give us 285 square feet for that room. We then add the 2 room measurements together. 120 feet plus 285 feet is a total of 405 square feet for both rooms. The last thing now is to convert square feet to square yards. To do that, we take our square feet and divide by 9. Square feet divided by 9 is square yards. So if we take 405 square feet divided by 9, that will give us 45 square yards for our answer. A problem might say that a person bought 1 square mile plus an additional 150 acres of land. If the land was purchased for $2,500 per acre, what was the total purchase price? What they're testing us on here is, do we know what 1 square mile of land is? 1 square mile is a section of land. 1 square mile is called a section of ground. A section contains 640 acres. That you simply have to memorize. Every section of land contains 640 acres. So if a person bought 1 square mile plus an additional 150 acres, to figure out the total, we would have to add 640 acres for the 1 square mile plus 150 extra to get a total of 790 total acres of land purchase. In this case, the purchase price is $2,500 per acre. So to finish up, we'll take 790 acres times $2,500 per acre to arrive at a total purchase price of $1,975,000, and that would be our answer. A problem might say that a rectangular piece of property with a total area of 5 acres had a total frontage of 600 feet. What would be the depth of this piece of property? Let's remember a couple of things. First off, every acre contains 43,560 square feet. So let's draw a rectangle for our total area. And let's take 5 acres times 43,560 square feet to get the total square footage for this piece of land, which would be 217,800 square feet. So in our rectangular piece of land, we have total square footage of 217,800. It then tells us that the total frontage, the width of the entire property, is 600 feet. What would the depth of the property be? If length times the width is square footage, then going backwards, square footage divided by the length has to be the width. So to finish out, we will take the total square footage of 217,800 square feet and divide by the frontage, or the length, if you will, of 600 feet. That would give us the depth of this lot to be 363 feet. Our answer again is 363 feet. A problem might say that a triangular-shaped piece of property had a base length of 200 feet and a height of 150 feet. If this piece of property sold for $20 per square foot, what would be the price? We have to know the formula for figuring the area of a triangle. The formula is 1/2 the base times the height. So we can draw our triangle here, and our base is 200 feet, the height is 150. So we need 1/2 of the base. So 200 feet, 1/2 of that, or divided by 2, would be 100 feet. So my base is now going to be 100 feet times the height, which is 150 feet. So 100 feet times 150 feet will give us 15,000 total square feet for this piece of land. The price is $20 per square foot. So to finish out, we would take 15,000 square feet times $20 per square foot to come up with the total purchase price of $300,000. So $300,000 would be our answer. A problem might say, what would be the square footage for the property shown? If you look at the diagram, we have a piece of property that is an odd shape. It is not a rectangle nor a triangle, rather a combination. So let's make it a separate rectangle and a separate triangle. Let's first off put a horizontal dashed line to break this bottom part of the land up into a rectangle. So we have 150 feet for the base measurement, or the width across the bottom. The length on the left, when we cut this off with an imaginary rectangle, will be 130 feet. So we take the length times the width. If we take 150 feet times 130 feet for the length times the width, that gives us total square footage of this rectangular piece of land to be 19,500 square feet. Now then, what's left on the very top piece is our triangle. Notice on the left-hand side we have 130. On the right-hand side we have 200 feet. So if we wanted to figure out the measurement for the top part only, going vertically, we would need to take 200 feet minus the 130 feet, that would leave us 70 feet here vertically for the distance for that particular triangle, 70 feet. Notice with the triangle, that would be in essence the height of our triangle, or 70 feet. The base of this triangle would be 150 feet. We get that measurement from down below. The formula for a triangle is 1/2 the base times the height. So 1/2 the base of 150 would be 75 feet. So we take 75 feet times the height of the triangle, which is 70 feet. That would give us 5,250 square feet. So for the total square footage of the property shown, it would be 5,250 square feet plus 19,500 square feet for a total square footage of 24,750 square feet. Let's practice on some math problems involving depreciation and appreciation. A problem might say that a property had a land value of $30,000, improvements of $200,000 with an annual depreciation rate of 5%. What would be the amount of depreciation after 6 years? Remember that on the test we use straight line method depreciation, which is equal amounts each year. They give us 1%, which means we'll draw 1t. Our depreciation rate of 5% will go on the bottom right. The improvements of $200,000 will go on the bottom left for the whole amount. Please remember that land never depreciates, only improvements such as structures we build on the land. So we will take the $200,000 of improvements, like a structure, times the 5% depreciation rate to get the part, or the $10,000 of depreciation per year. We need 6 years worth of depreciation, and remember, we always use straight line method, which is equal amounts each year. So to finish out, we simply have to take the $10,000 of depreciation per year times 6 years to get the total depreciation of $60,000 for our answer. A problem might say that a property had a land value of $20,000, improvements of $100,000, and depreciation in the amount of $30,000. Using the cost approach to value, what would be the estimate of value for this property? With the cost approach, we take the value of property as if new, then step 2 we subtract for depreciation, and then step 3 we add in the current land value, because recall, land never depreciates. So in this problem, here's what we would do. We would take the $100,000, the cost of the improvements as if new, then in step 2 subtract out $30,000 for the depreciation, and then step 3 add in the current land value of $20,000. So $100,000 minus $30,000 plus $20,000 would give us a depreciated estimate of value for the property of $90,000. Our answer would be $90,000. A problem might say that a property was purchased for $130,000, assuming an appreciation rate of 6%, which means the property is going up in value each year by 6%. What would be the value for this property after 3 years? Appreciation is just the opposite from depreciation. With depreciation, we always use straight line method depreciation, equal amounts each year. With appreciation, we have to recompute each year how much the property goes up in value. So in this case, we need 3 years worth of appreciation at 6%, which means we'll draw 3 T's. In our first T, 6% goes on the bottom right for the rate. The purchase price was $130,000, which goes on the bottom left for the whole amount. Our formula tells us to multiply straight across. So we will take $130,000 times 6%. That would give us appreciation for the first year of $7,800. That would be the part that goes up on top. Then to figure the new value after year 1, we take the $130,000 of original value plus the $7,800 of increased value to get a total new value, starting for year 2, of $137,800. Let's go to our second T. We have 6% on the bottom right. Our value for year 2 is $137,800, which goes in the bottom left for the whole amount. Our formula tells us to multiply straight across. So we will take $137,800 times 6% to get the part, or the increase in value for year 2, of $8,268. So to figure out the new value at the end of year 2, we add the two numbers together. So we would take the $137,800 value plus the $8,268 in the increase in value to get a total of $146,068 for the value at the end of 2 years. We then go to our third T. Our 6% appreciation again goes in the bottom right. Our value for year 3 starts out at $146,068, which goes in the bottom left for the whole amount. So we will take $146,068 times 6% to get an increase in value in year 3 of $8,764. So to get the total value at the end of 3 years, we would take the $146,068 plus the increase of $8,764 to get a total value after 3 years of $154,832. Again, our answer is $154,832. Let's look at some math problems involving value. A problem might say that a commercial property had a value of $800,000 with a capitalization rate of 6%. What would be the net operating income for this property? We have 1% given to us, so we draw 1T. The 6% capitalization rate is our rate, the percentage, which goes on the bottom right. The total value is $800,000, which goes on the bottom left for the whole amount. Our formula tells us to multiply straight across. So if we take $800,000 of value times our 6% capitalization rate, which is kind of like a rate of return, that gives us a part of $48,000, which goes up on top, and that's our answer. The $48,000 represents the net operating income. The value times the cap rate gives us our net operating income of $48,000. A problem might say that an 8-unit commercial property rented units for $2,000 per month. The complex had a 5% vacancy rate with expenses that were 30% of effective gross income. If the capitalization rate was 8%, what would be the value of this property? This problem gives us 3 percentages, so we'll draw 3 T's. Let's first off start off with the total potential annual gross income of this commercial property. So we will take 8 units times $2,000 per month per unit times 12 months, because we need to bring this to an annual gross income figure, which will give us $192,000. Let's then go to our first T. Let's figure out that 5% vacancy, because the 192 figure, the 192,000, would be the total possible gross income if it was never vacant. That is hardly ever the case. So if they give you a vacancy rate, you must use it, so we'll have to subtract out 5% for the vacancy. So in our T, the 5% goes on the bottom right for the rate, the $192,000 goes on the bottom left for the whole amount, and our formula tells us to multiply straight across. So we would take $192,000 times 5% to give us our part of $9,600, which represents the amount of vacancies. To arrive at what is called the effective gross income, we take the possible gross income minus the vacancies. So we would take $192,000 of possible gross income minus $9,600 of vacancies to arrive at $182,400. That's referred to as the effective gross income. That's effectively how much money came in the doors. We then need to subtract out our annual operating expenses. And notice in our particular problem, it says that the operating expenses were 30% of the effective gross income. So in our next T, the 30% goes in the bottom right. On the bottom left, we'll have our effective gross income of $182,400. Our formula tells us to multiply straight across. So we'll take $182,400 times 30%, which will give us our part, or the annual operating expenses, of $54,720. We then need to subtract the expenses from the effective gross income. So we'll take the $182,400 of effective gross income minus the operating expenses of $54,720, and that would give us the net operating income of $127,680. As a review, here are the steps involved in going from gross income to net operating income. Step 1, we take the possible gross income. Step 2, minus the vacancies to arrive at what's called effective gross income. Step 3, minus the operating expenses to arrive at step 4, or the summation here, to arrive at the annual net operating income. So again, gross income minus vacancies minus expenses is the net operating income. Let's go to our third T. To arrive at the value of the property, we have an 8% capitalization rate, which goes on the bottom right for our rate. The net income, the net operating income of $127,680 is always the part. It goes up on top. Our formula tells us to take the top and divide by the bottom. So we will take $127,680 and divide by 8%, and that will give us a value, our whole amount, of $1,596,000. Our answer again would be $1,596,000. The net income divided by the cap rate gives us our value. A problem might say that a 6-unit apartment complex rented each unit for $600 monthly. Using an annual gross rent multiplier of 10, what would be the value of this complex? With a gross rent multiplier, we multiply, hence the term, we multiply rent times a particular multiplier number. This is used primarily with rental properties. The multiplier can be either an annual multiplier or a monthly multiplier. In this problem, they give us an annual multiplier of 10, which means we need to multiply that times annual rent. So let's figure out the annual rent on this apartment complex. We'll take 6 units times $600 in rent each month times 12 months to arrive at the annual income of $43,200. So then to estimate the value, we take the annual income of $43,200 times our annual multiplier of 10 to give us a value for this apartment complex of $432,000. Our answer would be $432,000.